Hey there, let's just jump right into this explainer. Today, we're going to crack the code on how to perfectly balance and solve algebraic equations. Whether you're seeing algebra for the very first time or you just need a quick refresher, mastering how to isolate variables is literally the foundational skill you absolutely have to have.
So, here's our mission for today. We're going to use inverse operations and properties of equality to solve equations, explain exactly why each step preserves that equality, and then prove our answers are right by checking them with substitution. Let's get to it.
Okay, so the core rule of algebra is this. To preserve equality, whatever operation you apply to one side, you have to apply in the exact same way to the other. Think of an equation like a perfectly balanced scale, right? If you take weight off one side, you've got to take the exact same amount of weight off the other, or else the whole thing tips over.
Now, to get a variable all by itself, which is always our main goal, we use what are called inverse operations. This basically means we look at what's happening to the variable and we do the exact opposite to undo it. Addition, subtraction, they're inverse operations. They're basically the perfect tools for isolating our unknown variable. Let's look at our first practice model and see how this actually works. We're starting with the equation x plus 7 equals 19. Here, x is our unknown variable, and it's kind of like a mystery box. We need to figure out what number is hiding in there to make this mathematical statement true.
Since 7 is being added to x, we need our inverse operation, which is subtraction. We subtract 7 from both sides to keep our equality perfectly balanced. On the left side, positive 7 minus 7 just zeroes out, leaving the x completely isolated. And on the right, 19 minus 7 leaves us with 12. Boom, x equals 12.
But wait, how do we know we're actually right? Well, the best part about algebra is you can always verify your answer by substituting that 12 back in for x in the original equation. We literally just swap the letter x for the number 12. 12 plus 7 is 19, proving that 19 does indeed equal 19. The equation is balanced, and our answer is absolutely correct.
All right, let's tackle another one. Y minus 5 equals 12. Keep your eyes peeled for that inverse operation. Remember, our ultimate goal here is to isolate that variable y on one side of the equal sign. You've totally got this. This time, when we look at our variable, we see a subtraction of 5. So what's our inverse operation? Addition. We apply the addition property of equality by adding 5 to both sides. On the left, a negative 5 plus 5 gives us 0, leaving just the y. On the right, 12 plus 5 gives us 17. So we've successfully isolated y to equal 17.
And here is the magic of our verification process once again. Substituting 17 for y confirms our equation is perfectly balanced. 17 minus 5 equals 12, leaving us with a totally true statement, 12 equals 12. Seriously, there is no guessing in algebra when you use substitution to check your work.
Okay, now it's your turn to do some heavy lifting. If we have an added constant of 14, like in the equation m plus 14 equals 30, what is our very first step? Take a quick second to think about what operation will effectively undo that addition.
Did you say subtract 14? If so, you hit the nail on the head. You absolutely must subtract 14 from both sides because subtraction is the inverse of addition. That's what isolates the variable while keeping everything balanced. If you accidentally added 14, you'd just be piling more onto that left side, ending up with m plus 28. That moves you in the exact wrong direction away from isolating the variable. Let's try a different kind of check. We need to determine if a proposed value of 9 satisfies this equation, k minus 4 equals 13. Now, we don't even need to solve for k from scratch here. We can just use our incredibly powerful substitution skills. So, by plugging 9 right in via substitution, we get the statement 9 minus 4 equals 13. Well, when we evaluate that expression, we get 5 equals 13, which is clearly false. That means 9 is definitely not the correct solution. And honestly, this is exactly why checking your work is such a game changer.
When we look at our core mathematical practices, attending to precision by always checking your work is what really makes you an excellent problem solver. By verifying your solutions through substitution, you're actively ensuring your mathematical reasoning is completely rock solid.
All right, let's quickly recap what we covered in this explainer. First, inverse operations, like subtraction to undo addition, allow us to effectively isolate variables. Second, to preserve equality, the exact same operation must always be applied to both sides. And finally, checking a solution by substituting it back into the original equation ensures absolute accuracy.
I'm going to leave you with one final equation to really test your new mastery. How will you find and verify the value of w in the equation w plus 8 equals 21? Remember to identify your inverse operation, preserve equality, and verify. If you can perfectly balance this equation today, what complex real-world problems could you balance next?